Half of them are covered in Part A, and the other half of the viruses are covered in Part B. Similar to as we've done in the past with the other pathogens, what we're going to be doing is looking at symptoms and signs for each one, specific terms attached to them, whether it is or isn't communicable or endemic or things of that nature, mode of transmission, what organ system it affects. So similar to what we've done before. If you take a look at your outline, you'll notice that somewhere towards the end there's a highlighted, bolded area where I list what you need to focus on for each virus. I wanted to bring in coronaviruses to talk about it and COVID-19 specifically to make sure everyone actually understood what was going on, because it's ridiculous to compare it to a traditional flu when it is completely different. I've decided to turn that into an actual assignment for the last week. So we're just going to continue on with the ones I had intended on doing. So let's start with influenza. This is a respiratory virus, which means its mode of transmission is in fact airborne. It's an RNA enveloped virus that has an incredibly high mutation rate and is very communicable, whether it's airborne or direct contact, so sharing, for example, a utensil with somebody. When you take a look at this picture, what I'd like you to notice is the top looks one way and the bottom looks a little different. So the top is referred to as antigenic drift and the bottom is antigenic shift. If you take a look, there's all the glycoproteins, also known as spikes, that we talked about in the first part of Unit 5. And with these spikes, there's two different colors and one type of RNA in its core. After one mutation, notice the spikes have changed and there's a little bit of red in the genetic mutation or in the core. Now mutation 2, there's more color and again the spikes have changed. Whereas on the bottom, not only are the spikes changing, but also the genetic core is completely crossing over and there's a full what's known as a reassortment. Here you were looking originally at an influenza virion from an animal versus one from a human. So there are many different examples of how influenza over time mutates and varies. This first picture, I'm not going to spend too much time on this slide, but I want to mention in mainland China, there are influenza viruses in quail, goose, and foal, for example, whereas in the Hong Kong poultry market, two of the animals, quail and chicken, also led to a shift where it was now passed on to humans. There isn't always a jump of species, as it's called, and when there is, that's usually when it tends to be a little bit more dangerous. SARS was something similar, as well as the avian flu. If you take a look down here, number 1 and 2 talk about two possible ways that new strains of the flu can actually come about from this jumping of species. As I had mentioned earlier, the H and the N are hemagglutinin and neuraminidase, the spikes. After each one, you can think of a number sign because it's a ratio between the two of them. Pretty much everyone has heard of H5N1 or H1N1. Notice those are both listed under swine as well as humans. So this is giving you the different ratio of the glycoproteins on the surface of the RNA influenza virus and which particular animal will house or home that strain of influenza. A couple unique things about this is it changes every single year. As you saw in the first slide, it has an extremely high mutation rate. And this mutation rate actually tends to change annually, which means every year it's different. You'll hear that the vaccine is X amount of percent effective, 20%, 30%, 15%. The higher effective it is, that's essentially telling you that the better likelihood that they guess that H and N ratios of the particular virus that particular year. They're not always very good at it. Some years you'll hear that the flu vaccine is only 10 or 15% effective, and that's pretty low in the scheme of things. So a concept that a lot of people might not realize is the migratory patterns of birds helps determine flu season, when it begins, when it ends, and how long it's actually going to be. And this migratory pattern is what changes annually. If you take a look right here, these are areas where the H5N1 avian influenza, which was a pretty high communicable and troublesome type of influenza strain occurred in 2013. The red ones are areas where it was confirmed in human. Why was this a big deal? Because this is a jumping of species. Avian implies birds, so from birds to humans, which is a very rare thing. So pandemic, I don't think I have to explain this word at all because we're hearing it every 5 minutes on the news and the TV. But what you may or may not have heard is that in 1918, the H1N1 influenza, known as the Spanish flu, took out a whole lot of people. So we're over 20 million deaths worldwide. And then at times it actually reappears. So please take a look at this chart up here and look over those numbers a little bit. Culturing vaccines is always going to come up because please remember that I mentioned it is the allantoic cavity of eggs where the flu vaccine is actually cultured. I also mentioned someone like my grandmother is allergic to egg whites, which is albumin, so not everybody is able to have this particular flu vaccine. Why is it important that you remember it's cultured in an egg? Because ultimately viruses need a live host. So remember, this isn't like bacteria where you can simply grow it up in a little bit of broth or on an agar plate. So next we're going to talk about RSV. RSV, written out, is respiratory syncytial virus. Again, short for RSV. This isn't like bacteria. You can easily just remember the abbreviations and it's perfectly fine. So RSV, the syncytial part that we mentioned is the CPE or cytopathic effect. Remember, this is when they group together into big bunches. You can see it right here in this picture where it's being bunched and chunked together. This is incredibly common in children under the age of 1, and the symptoms tend to mirror and look like pneumonia. So what you have is really badly obstructed breathing, and the bronchioles actually have swelling, and that swelling causes the bronchial walls to get poofed up, which is why the breathing is obstructed in the first place. Most of the kids will actually recover from this in about 1 to 2 weeks, but often the kids do have to be hospitalized. So again, children under the age of 1. So next we're going to talk about herpes simplex virus. There is type 1 as well as type 2. For type 1, I want you to think of it as oral. And for type 2, I would like for you to think of it as genital. If we were in class, I'm pretty sure we would be having a really long discussion about now over is a cold sore herpes, and the answer is some form of. It's a fever blister, so yes, it is related to HSV type 1. So type 1, again, oral. Type 2 is genital. This is highly communicable, which means you can, in fact, pass it along. Another term for this is that it is contagious. It's sequelae, so there are secondary and other infections related to it, and it is also latent, especially the genital one, more so than the oral one, which means it can go to sleep or lay dormant in the body for a little while, and then it tends to come back in outbreak, as it's called. So there are all kinds of lesions. The incubation period is short, from 2 days to 1 week. You can take a look at that link if you'd like in the original Module 5 for our class. So not only do you have lesions, but you also have blistering of the skin. So this is an example of type 1. This is the shaft of a penis. If you take a look, you can see that there are all kinds of rashes and little blistering bubbles of the skin. Little bit of information here. Please read through this because I'm just going to give you a couple things to pay attention to. First and foremost, 80 to 90% of people that are infected with genital herpes are completely unaware that they have it. Now with HSV2, which is the genital kind, it is very often passed on during the passage through the birth canal of a symptomatic female. In other words, it's passed on from the mother to a newborn child. And it's important to realize that 60 to 70% of the time when this is passed on from mother to child, in a newborn, it has a 60 to 70% fatality rate. That is incredibly high. Next, we're going to look at human papillomavirus. For short, this is just simply HPV. And HPV has many different types, or what's known as many different strains. But the two most paid attention to and studied are 16 and 18 because both of them in women have a tendency to lead to cervical cancers. Most of these infections, when you first come in contact with it, will be cleared away early on by the immune system. This is in fact an STI, or a sexually transmitted infection, that is again associated with cervical cancer. So the incubation period for this guy is a really, really large range. It could be as small as 1 week, or it can take all the way up to 1 year to become symptomatic and show the papillomas, which are the signs and symptoms of an HPV infection. If you take a look at this chart right here, I would like to point out a few things. First and foremost, when someone becomes exposed, it can be an acute infection, which means a quick onslaught of symptoms. If it is subclinical, another name for that would be asymptomatic, so there are no symptoms that are showing when the person is infected, and it can go latent that it is sleeping. If it is in fact clinically evident, which also means that the patient is symptomatic, then one of many things can happen. It can be a persistent infection, it can turn into invasive cancers, or simply start off as lots of lesions and papillomas in the genital area. The HPV, as I had mentioned before, it has a very strange incubation period. It goes literally from 1 week to a year. It impacts the urogenital tissue. Again, on the shaft of the penis, notice these papillomas, unlike when we talked about herpes simplex virus, these aren't just blistering. These look like actual blisters, like little blood blisters. They also can look like warts on the actual fingers. And this is one of the most common STIs in people under the age of 24. 6.2, where is the statistic? 6.2 million Americans literally annually get a genital HPV infection each year. I love this picture in class because it makes everybody cringe and completely shove their legs together as I show it, so of course I find that entertaining. These are extreme genital infections. So I want to point out these are known as papillomas. That is the side effect of being positive for an HPV infection. And no, you don't get HPV and guaranteeingly have these issues. The shaft of this penis, to me, I always think of cauliflower, which is bad because I ate cauliflower yesterday. But that is a completely extreme papilloma. These are vaginal lips with extreme papillomas. And this is between the buttocks where, again, it is extreme. So realize that HPV can be pretty mild to where a person seems initially asymptomatic, and it could be latent, but gone to the full extreme. These are examples of what it could look like.